we're gonna start with the intro. I believe some people might join while we are in the conversation with Heidi, so that's fine. My name is Marcela, and I'm here in Colombia. I'm going to tell you a little bit the story behind the scenes of why we are having this amazing webinar. Of course, thanking Heidi for joining us. We started a project in December here in Colombia called Cumbres Blancas, which means white peaks. And it is the idea of, first of all, acknowledge that we have 6 tropical glaciers in our country. Most Colombians don't know this fact. Indeed, I was one of them until December, that I read an article in the newspaper and I realized that we only have six of them, and they're melting in a very accelerated way. In 30 years, the statistics says that they will disappear. So we created a group in which our goal is to go and do these 6 summits, peaks, which is a very delicate situation as well. 3 of them are blocked by indigenous communities, and it's not that easy to have access. But so we're starting that conversation and dialogue with these indigenous communities and with other organizations around Colombia. We have in our team the glaciologist in Colombia, Jorge Ceballos, which is actually the only one and the last one, as they call him. And the purpose of the project is to bring awareness on these glaciers through a book and a documentary. Of course, through a lot of social media and pedagogical efforts, education efforts, and this committed group of people from recognized mountaineers from Colombia that have been to most of the continental high peaks. And this is a little bit what we are doing. We just did a month ago our first summit. It's called Santa Isabel, and it's the most critical one. It was an amazing experience. So in all this process, of course, after seeing One Strange Rock, we were very shocked by the global situation of glaciers and how nobody's really focusing on the ones that are going to disappear first, which are the ones closer to the Ecuador, as it is our case. So after seeing One Strange Rock, I immediately reached out to Heidi through Instagram. We had a lovely chat on WhatsApp, and we were really happy to hear that she was wanting to be part of our team, and we're hoping to have her and hug her in person soon, hopefully in September or in November for our 2nd or 3rd summit. So without further ado, I want you guys to enjoy this insightful talk that I'm sure we're all gonna learn a lot. And the idea is that we can keep doing amazing chats with Heidi. So this is the first one of hopefully many. And Heidi, I'll leave it to you so you can amaze us with this amazing eye-opening content for most of us.
Thank you so very much, Marcela, and thank you for the very kind introduction. Indeed, I'm so glad to be a part of this wonderful project. I think what you guys are doing is really wonderful. It takes a lot of efforts, really, to talk about tropical glaciers today, especially in countries where people have no idea that these glaciers actually exist. And these glaciers are not going to be around for very long, and it's really our mission to tell people the stories of these glaciers and to tell them how important they actually are. So yeah, I'm a glaciologist. This is my job. I'm more focused on glacier dynamics in the polar regions. This is where I did my PhD. At the University Center in Svalbard. And I became curious about tropical glaciers a few years ago. I had just finished my PhD in Svalbard, and me and my brother actually attempted to climb Mount Kilimanjaro. It's a very popular climb, but this was really my first encounter with the tropical glaciers. And as many people would tell you, it is quite shocking to go and see the states of the glaciers over there. But for me, this was the first moment when I thought, okay, there's actually something very important to do on these tropical glaciers. And perhaps we can raise awareness about how they are reacting to climate changes. So because I'm going to be talking about glaciers to some people who are glaciologists and some people who aren't, I've seen the participants list. I think it's good to start from the very, very beginning and go through the basics with, for example, what is the glacier and how does it work? Because this has implications on the reason why glaciers are reacting to climate changes. So the recipe for a glacier is very simple. It only takes a very long time. For a glacier to be able to be created, what you need is snow. So snow is by far the main ingredient. And what you want is the snow to survive for more than 1 year. Like, for example, the reason why I don't have a glacier in my back garden in France is because in the summer, the snow that we get during the winter, in the summer, it completely disappears. So we don't have an accumulation of snow year after year. But if you live really high up on the mountains, really, really high up, especially if your location is close to the tropics, or if you live at lower elevation, closer to the poles, this is where you can get snowfalls and snow layers that will survive for the whole year. And this is truly what we want. We want this accumulation to take place year after year. And it takes definitely more than 4 years. It's a very slow process, but what will happen is that the newer snow layers will crush the older snow layers at the bottom, at the base of this multi-layered cake. And so you're starting to get from snow to glacier ice. And this is the process by which glaciers are formed. And what is quite fascinating with glaciers is that they actually all move, even though when you look at them, nothing seems to be happening. They seem to be pretty static, very boring, but actually all glaciers move under their own weight. And some are moving very, very fast. When I say fast, it could be a few meters per day. And some are moving extremely slowly. It could be a few centimeters per year. And so to illustrate what I'm saying, I wanted to show you this video. This is a time-lapse video. This is actually from Mount Everest. So you might be recognizing the mountain. In the top left corner, this is the highest summit on Earth. And from Mount Everest, you've got this wonderful glacier flowing down the mountain. And this is called Kuru Glacier. It's the big tongue you can see between the two mountains, between Everest and Lhotse. And if you look very closely, actually, on the bottom left corner of your screen, you get all these little colored dots. These are actually tents because during the months of April and May, this is the season or the main time of the year to climb Mount Everest. And so this is EBC, Everest Base Camp. And the reason why I wanted to show you this picture, but most importantly, the video that will come right after this, is because Kuru Glacier is a very active glacier. It moves extremely rapidly. So what I will show you now is a little time lapse from the Extreme Ice Survey. So they put a time lapse camera taking pictures every day for 2 years of the glacier. And this is what truly happens when you accelerate time. You can see that the glacier is extremely active. It's even moving Everest Base Camp with it. And this is quite a tricky situation. So here they're actually rewinding the video. So the glacier is not flowing up the mountain. So the glaciers are always flowing down. But you can imagine it's a tricky situation because if you want to climb Mount Everest, you have to cross this glacier quite a few times and jump over massive crevasses because it's such a fast moving glacier. So this one is moving at about 4 meters per day. So the landscape is changing all the time. But what's important is because glaciers are constantly moving from high elevations to low elevations, they lose parts of their ice every summer or during every dry season. So for example, if you look at this picture, this is a picture of Morteratsch Glacier. This is in the Swiss Alps. And the picture is taken in the summer because you can see at lower elevations, there is no snow anymore. And this is where we have what we call the ablation zone of the glacier. So this is the lower part of the glacier. This is where the ice is pulled down at lower elevations. And this is where naturally the glacier will be stripped of its snow, and some of the ice will melt every summer. But for the glacier to survive, for the glacier to still produce ice, in the summer, you still need that snow to exist. And this is what we call the accumulation zone. And this is in the upper parts of the glaciers. So if the glacier is still a healthy glacier, you will still have snow on the glacier in the summer or during the dry season. If the glacier is not very healthy, is in a bad situation, then you can clearly see that during the summer is because there is no snow left anymore on the glacier. So this is a very important telltale sign when you look at these glaciers. So in the world, there are about 190,000 glaciers. So this is quite a lot of work for us glaciologists, fortunately. And I'm sure that now you understand a little bit better how glaciers form and why we find them in particular places in the world. So as you get closer to the North Pole or to the South Pole, this is where the glaciers can reach very low elevations down to sea level. And if you, to the contrary, get closer to the equator, this is where glaciers can only survive if they go very, very high up. And this is, of course, what we're going to be talking about today. So tropical glaciers are truly magnificent. There are not many of them left in the world. But what's interesting is that they behave differently from alpine glaciers in other places in the world. And so this is what this conference is all about, is to tell you what these glaciers are, why are they important, and how are they reacting to climate change. So I know that tropical glaciers, when I tell people about tropical glaciers, they're always like, what? How can there be ice in the tropics? It really sounds like an oxymoron, but actually there is still, believe me, some ice in the tropics. And of course, the wonderful people from Cumbres Blancas know all about it. So there can still be ice in the tropics because of what we call the lapse rate. So as you get higher up in elevation, the air gets thinner, and it's harder for this air to preserve the heat that is getting from the sun. So typically, as you go up 1 kilometer, you lose about 6 to 7 degrees. So if I take an example of Indonesia, in Jakarta, let's say today it is 32 degrees Celsius. And if you go to Puncak Jaya, which is one of the mountains that welcome some tropical glaciers still today, the mountain culminates at 4,800 meters, 4,900 meters. At this altitude, we're just below zero because of this lapse rate. So indeed, ice still exists in the tropics because of that phenomenon. So if we look at the distribution of tropical glaciers, what I will do is follow the distribution of Casa et al. From a paper published in 1996. And they define the main tropical regions for glaciers as the Andes, of course, mostly the northern Andes, East Africa, and also Indonesia and Papua New Guinea. I know that some people take Tibetan glaciers into account as tropical glaciers, but at least for this talk today, this is what we will stick to these 3 different regions. So how many tropical glaciers do we have in the world today? So we still have quite a few. So out of 200,000, of course, it doesn't represent a huge amount. It's about 3,000 tropical glaciers we have in the world. So in Peru holds about, I think it's 76% of all the tropical glaciers in the world. Bolivia, quite a lot. Colombia, 71. And I know that Marcela mentioned that there are 6 glaciers. This is all depending on how you delineate the different glaciers. So in glaciology, when we see glaciers that come from different sides of the mountain, for example, that behave differently, these are different glaciers. But of course, when you have a complete ice cover over one mountain, you can say that this is one glacier. I'm not too picky about this. Then you've got Chile, Argentina, Mexico still has some tropical glaciers, Venezuela as well. Then for Africa, Tanzania, of course, this is Mount Kilimanjaro, still has quite a few glaciers. Uganda, Congo with the Rwenzori Mountain, 13 glaciers. Kenya, 7 glaciers with Mount Kenya. And then poor Indonesia, so they just have a handful of glaciers that are barely surviving. But I will show you more what these glaciers look like. Because it's important, these glaciers don't look the same depending on whether we're looking at Africa, whether we're looking at the Andes or Indonesia. They look different, so they behave differently. If we look at Peru, for example, so that holds the largest population of tropical ice masses in the world, this is what some of these glaciers look like. So they are what we call hanging glaciers. They are really high up on the mountains, just hanging in there. We've got cirque glaciers, some valley glaciers as well. And this is the Cordillera Blanca. So it's about 200 kilometers long, and it has several peaks over 6,000 meters high. So you understand why there are so many tropical glaciers left in Peru. This is the stunning Cotopaxi in Ecuador. This is a stratovolcano, so it's found about 50 kilometers from Quito, and it culminates almost at 5,900 meters, and it's one of the world's highest volcanoes. And you can see it looks very different. Look at the ice, it looks completely different from what we have in Peru. And actually, many of the tropical glaciers are found on volcanoes. Volcanoes can be very high up. And so when they are dormant, when they behave, the ice masses can be quite happy over there. Then Indonesia. So, I was telling you there are only a handful of glaciers left in Indonesia. This is Puncak Jaya. It's also known as the Carstensz Pyramid. It's an important summit for mountaineers because it's one of the 7 summits. And this culminates at 4,884 meters above sea level. So it's still quite high up, it's still a big summit to climb, but it's probably not high enough for these glaciers anymore. Then let's move on to Africa. In Africa, we have between Uganda and Congo this wonderful mountain range that is called the Rwenzori Mountains. These are also called the Mountains of the Moon, actually. It's quite a poetic name. And they are in a region that is extremely wet. So these glaciers actually still get quite a bit of snow. And they don't matter a lot in terms of the water they bring to the region because there's so much precipitation in the region anyways. So there are still 13 glaciers there. And what's very interesting about these glaciers is that they are actually one of the sources of the Nile River. So although they might not be very important for the region itself, they might be even more important further along the Nile. And they are culminating at 5,109 meters high. And of course, probably the most famous of them all is Mount Kilimanjaro in Tanzania. And the reason why I also wanted to show you pictures of these glaciers is that because they're very different. They're very different from all the other tropical glaciers we have. These are tropical tabular glaciers. And in glaciology, we really rarely talk about tabular glaciers. We talk about tabular icebergs in Antarctica. But these are tabular glaciers that are very rectangular, so they look a bit like a table. And what's interesting about these glaciers is that their margins are completely vertical. So you've got these big vertical cliffs. And these tabular glaciers are found on the flattest parts of the plateau of Kibo, which is the highest caldera on Kilimanjaro. This is the only caldera where we find glaciers. But you've got also another type of glaciers on Kilimanjaro, which are these slope glaciers. As you can see, they also have these vertical cliffs, but a lot less pronounced. And it's quite good not to have too many of these vertical cliffs, because if you have a vertical cliff, it cannot accumulate snow on top of that vertical cliff. But if you have this kind of sloping down margins, it's a little bit better for the glacier and enables it to accumulate more snow all the way to the margins of the glacier. So why are these glaciers so important? Well, tropical glaciers really, really matter for so many reasons. But the main reason is that they contribute enormously to the water budget of the places around these glaciers. So when I say the water budget, is basically how much water comes down from these glaciers. And glaciers actually make a huge difference during the dry seasons or during the summer. This is when all the snow has melted. It doesn't rain anymore, so you can only rely on these glaciers to bring some water by melting to the regions around them. So glaciers matter, of course, for agriculture, for potable water, for power generation, and for the integrity of some very specific and very fragile ecosystems. And I'm going to talk about this in greater details. But first, let's take a look at what is really affecting tropical glaciers today. And there are some wonderful pictures of Mount Kilimanjaro. This is from Red Bull, actually, where they sent this climber to climb what we call the ice sails of Mount Kilimanjaro. So these vertical ice cliffs that are not connected to any big glaciers and any active glacier anymore. So what's affecting these tropical glaciers? Well, you know, of course, when you think about glaciers, you think about temperatures. And we all know today that our world is warming. Some regions are warming much faster than others. And at least in the tropical Andes, we know that the climate is really warming up. There is a strong control on the mass balance, on the health of glaciers because of the temperatures. But what's also interesting is that temperatures are not the only big players. Here I'm only talking about the tropical Andes, but in other places, other factors are affecting tropical glaciers. First of all, tropical glaciers are very close to the melting point of the ice. So as you know, ice melts at 0 degrees Celsius, and this melting point actually changes depending on the pressure that is being done on the ice. So for example, if you have a very thick glacier that is, let's say, 2 kilometers thick, these are big glaciers that we find on the ice sheets, the ice can melt at -1 degrees, for example. And what's happening to these ice masses in the tropical regions is that they are very close to the point of melting. So if the air temperature increases by, let's say, 0.5 degrees or 1 degree, that makes all the difference between solid ice, between solid water, and liquid water. But if you take ice, for example, in Greenland or in Antarctica, ice that is at -5, -10 degrees Celsius, there it doesn't make a difference if it actually increases by 1 degree. I'm of course exaggerating a little bit, but it's just to show you that the tropical ice masses, because they are so close to the melting point, they are very sensitive to any changes in temperatures. But also moisture, which is the air content in humidity. How much humidity do we have in the air has a big influence on how much these tropical glaciers can melt. What we do know is that at least for Mount Kilimanjaro, we have detected that the region around Kilimanjaro is drying up, meaning that we have less and less clouds in the air, less and less fog, less and less cloudiness, which usually protects the glaciers from melting too much, from the strong shortwave radiation from the sun. So the less clouds you have, the more melt you have, the more ablation you have. And this is something that has been demonstrated for Kilimanjaro. But what has caused this drying up of the region? How come we got suddenly a region that was very humid around the mountain that got very dry? Well, we know that some regions around Kilimanjaro have become deforested massively. And forests are actually wonderful cloud catchers, and they actually transpire a lot. They reject quite a lot of humidity. And actually, this was a very good thing for the glaciers of Kilimanjaro. So this is also something we can act upon to kind of counteract these deforestations that are taking place. Also, something that has a very important role to play when it comes to the melting of the glaciers, especially in the Andes, is a phenomenon called El Nino, so the El Nino Southern Oscillation. This is something that happens regularly. It brings extremely high temperatures. And usually it brings a lot of precipitation, but it's only good for glaciers if the precipitation falls as snow, not as rain. Glaciers don't want rain, they want a lot of snow. And so El Nino, we might think, oh, great, lots of precipitation. This is when we see the Atacama Desert blooming, it's raining a lot. But it only works for glaciers if there is snow. And as the temperatures are increasing, the limit between snow and rain goes further and further up, and these glaciers are being affected a lot by having more and more rain falling onto them. But also size matters for glaciers. It might sound a bit funny, but actually the smaller the glacier is, the more it will react to climate change and the faster it will actually react to climate change. So this is a Google Earth image of the glaciers of Peru, of the Cordillera Blanca. And actually the glacier in the middle is 2 kilometers long. And for a glacier, this is very, very short. You have to know that about 10% of all tropical glaciers are between 2 and 11 kilometers long. And 11 kilometers is still very, very small for a glacier. So that means that 90% of all the tropical glaciers on Earth are smaller than 2 kilometers. And look at what happens when you have very, very small glaciers. They're surrounded by bare rocks that haven't been colonized by vegetation. And these bare rocks can actually absorb a lot of heat. And there you have what we call a negative feedback taking place. The glaciers are retreating, leaving more and more bare rocks around them. The bare rocks can easily heat up, making the glacier melt even more. And this is a vicious cycle that accelerates the melt of the glacier. But then I want to tell you not this time about a negative feedback, but about another positive feedback. And bear with me, this is a little bit technical, but it's a very important process by which tropical glaciers melt even more. Basically, as the temperatures are increasing, the air masses are warming up. And when you have warm air, it can actually hold a lot more humidity, a lot more water vapor. And actually, water vapor is a very powerful greenhouse gas. So as the air is increasing, there is more and more water vapor in the air, much further up in altitude. The water vapor can heat up the environment around it a lot more, making the air masses even warmer. They are able to hold even more water vapor. And this makes the middle to upper troposphere much, much warmer. And this is at the altitude of tropical glaciers. So 4,000, 5,000, 6,000 meters high. These glaciers are being affected by actually the water vapor that is a very strong greenhouse gas. And then to finish, of course, aerosols. I'm sure my Colombian friends will immediately identify this beautiful mountain. This is the Nevado del Ruiz in Colombia. I'm sorry, I'm probably not pronouncing it very correctly. But this is a volcano, yet another one, a beautiful one that is covered by glaciers. And it doesn't look like it, but if you scratch the surface a little bit, remove some of the volcanic ash, this is ice. And glaciers and snow, they don't really like aerosols. They don't like these fine particles floating in the air that fall upon them on their surface. Because the glaciers are typically quite clean, they're quite white. The snow especially is very, very white. And it reflects a lot of the solar radiation. But if a glacier becomes dirty, like the ones you can see on the picture here, as they're becoming dirty, they can absorb a lot more of the solar radiation. And this is not good for them. It makes them melt even more. So of course, when you have volcanoes that are when you have glaciers directly located on top of volcanoes, it's not great for the glaciers. It makes them melt from underneath. You can see lots of fumaroles, but also the volcanic ash, if it's not too thick, it will actually accelerate the melting of these glaciers. So truly, when we look at tropical glaciers today, it is a race against time. Things are happening very, very, very quickly, and it's up to us to really make a difference. So when we look at glaciers in the tropical Andes, between Ecuador, between Peru and Bolivia, if it wants to show up. And we look at the changes in length of some of these glaciers, or the changes in area. You can see that these glaciers are actually retreating quite a lot. So they're getting massively smaller. And if you take a look at the, let's say, Brogy Glacier, for example, in Peru, which is the lowermost red line, this glacier has lost like, I don't know, 800 meters or even more in just a very short amount of time. And remember that these glaciers are actually extremely short. So losing 800 meters for a glacier that is 2 kilometers long is a massive, massive difference for the health of the glacier. So let's go through these different regions and take a look at how much of these glaciers have changed. So in Peru, 43% of glacier area has disappeared between the 1970s and 2010 in the 19 mountain ranges where we find glaciers in the country. So this is for Peru. When we look at Venezuela, so it doesn't have a lot of glaciers, but still glaciers have lost more than 95% of their area since the 1850s, so the end of the Little Ice Age. Colombia, beautiful Colombia, and especially this picture I think is incredible. Colombia, not good news to tell you guys, so I'm going to give you news from an old study from 2009, but it was predicting at the time that the total shrinkage of the Colombian glaciers could be foreseen by 2022. So it would be worth recalculating that, reassessing what is happening to these glaciers. But basically, they were forecasting a total disappearance of these glaciers, at least in the 2020s decade. When we look at Kilimanjaro, not better news. 86% of the 1912 ice cover has disappeared on Kilimanjaro. If the current climatological conditions are sustained, the ice fields atop Kilimanjaro and on its flanks will likely disappear within several decades. And this was published in 2009 by Thompson et al. Rwenzori Mountains, well, again, some other news. Extrapolations of trends in glacial recession since 1906 suggests that the glaciers in the Rwenzori Mountains will disappear within 2 decades. And this was published actually in 2006. So this is, it really shows that things are happening very, very quickly. And for many of these tropical glaciers, the 2020s will actually be the make or break. It will make a big difference. Mount Kenya, especially the Lewis Glacier, which is the biggest glacier on Mount Kenya, has decreased by 90% of its volume since 1934. And it's the glacier you can see on the picture here. So again, a really, really big difference. And Indonesia, so these poor glaciers are going to be there for very long. We have measured a 91% surface loss since the 1850s. So indeed, not good news when we look at tropical glaciers all around the world. Some are better off than others because they're much further up in elevation. So these are going to be the ones surviving the longest. But the ones that are below 5,000 meters are really, really struggling right now. So what are the consequences of the retreat of these glaciers? I think the picture I've shown here is quite striking. The picture on the right, so the poster that is being printed and displayed here, is 30 years before the current state of the glacier. And this is in Peru. It's the Pastoruri glacier in Peru. So massive difference there. So what is happening when tropical glaciers are retreating? So first of all, it does create a lot of hazards, a lot of problems for these regions. And in terms of hazards, I want to tell you about these lakes that are forming just in front of these tropical glaciers. So glaciers are actually very efficient landscape sculptors. They can create these over deepenings, these very deep glacial valleys. And as the glaciers are retreating and melting more and more, all the meltwater will gather in these over deepenings that have been carved by the glaciers. And what is damming these over deepenings, what is stopping the water from running away, is these glacial moraines. And the moraines are made of very loose material. This is rocks, gravel, sand. This is all the material that has been eroded and transported by the glacier. And it basically marks the last maximum extent of the glacier. But moraines are not good dams. They're not very solid. And as the water levels in the lakes are increasing, the dam is being put under a lot of pressure, and eventually it will burst open. And it will create what we call a glacial lake outburst flood, which is something that is studied extensively in the Himalayas, but it is already happening in Peru and in other places of the Andes as well. And believe me, Peru, they're really well aware of these glacial lake outburst floods. As early as the 1940s, they already had some really terrible accidents with lakes draining and killing thousands of people at the time. And so Peru reacted very quickly by building lots of dams. There were about 40 to 50 sites that were heavily monitored, and they tried to either build dams or to drain these lakes. But today there are actually hundreds of lakes growing in Peru. You can see on these pictures, and it's getting very difficult, like increasingly problematic, to have the funds, the number of people ready to be able to protect the people living downstream from these lakes. This is a really big issue. And this is a picture from the lake Palcacocha in Peru, and they installed all these massive siphons, so you can't see, but the lake is just in front of the guy on the picture. And unfortunately, there was a big calving of the glacier, so there was a big iceberg breaking off from the glacier, falling into the lake, and that destroyed many of these pipes that were trying to siphon the lake. Of course, water. I was telling you at the beginning, water is the main reason why we care so much about these tropical glaciers. And indeed, we're already starting to feel that we're getting less and less water from these tropical glaciers. And that is in many, many regions of the world. So last year, there was actually a very important study published in the Little World of Glaciology. This was from Matthias Huss and Regina Hock. And what they did is that actually they tried to calculate the peak water in many of the glaciated watersheds in the world. So what is peak water? So peak water is like peak oil. As you know, peak oil is like, oh, if we're getting more and more oil as we're discovering more and more up to a certain point, and then the amount of oil available will only decrease. Well, for glaciers, it's kind of similar. As glaciers are melting more and more, you might expect to receive more and more water, which is what is happening in many places in the world. Oh, that's great. Getting lots of water, it's fantastic. But glaciers can only sustain that for a limited amount of time. Eventually, the glaciers will reduce too much, will be too small to keep on melting and to keep on bringing a lot of water to these rivers. And peak water is something that Matthias and Regina have calculated for many of these places on Earth. And as you can see, the colors mean different time periods. And unfortunately, in many places in the world, we are already past peak water. And I'm not just talking about the Andes, I'm also talking about Europe. In Europe, we are just past peak water. So the Rhone River, the Danube are receiving less and less water from glaciers because glaciers are melting too rapidly. And so this is something really important to consider for potable water, for irrigation, for hydroelectricity, that if we're past peak water, we might get a significant decrease in the amount of water we get in these rivers. So rivers don't just depend on glaciers, but glaciers do matter a lot, remember, especially during the dry seasons. And in the world today, 1.9 billion people depend on glaciers, which is enormous. This is not just tropical glaciers, of course. As you can imagine, the Himalayas are playing a big part in this statistics I'm bringing you. But a lot of people are depending on glaciers for drinking water, for irrigation, for hydroelectricity. In the Andes, It's 75 million people who depend on glaciers to have water running, to have irrigation and hydroelectricity. This is a picture of La Paz in Bolivia, and it's 2.7 million people depending on water from glaciers. It's 20 to 30% of the water they get that comes directly from the ice. So as you can imagine, this is something very, very important. And we're already starting to see water crisis or water wars happening, not just in Peru, but in many, many other places. The problem in Peru, especially on the Pacific side of Peru, is that 80% of their water comes from glaciers. As you can imagine, this is huge, and it's going to become an increasingly huge problem in the future as glaciers are retreating more and more. Some countries are already fighting for progressive rivers, such as the Silala River that is shared between Chile and Bolivia. And Chile is claiming that they own the Silala River. Bolivia has just filed a counterclaim to say that actually they own the right to use the water from the Silala River. So indeed, this is only the beginning of what we're going to see. Water is a very precious resource, and especially in this region, is going to become as precious as gold. And if you think of water, of course, you think about hydropower, and many countries have built a lot of dams to produce a lot of hydroelectricity, such as Peru, Ecuador, but they're already starting to see that they're having less and less water in their dams because of the retreat of these glaciers. We also have to mention the social and cultural costs of the retreat of these glaciers. These are the wonderful Aymara population. And I know that Marcela has told me about these absolutely fantastic ladies that were climbing mountains in Aconcagua, which is really, really great to hear. These are populations that actually revere these high peaks. For them, they have a fantastic, a very important cultural significance and religious significance. These are the Kuru as well. They have some rituals that consist of going to certain glaciers to take some of the ice from the glaciers, and the water that is melting from the ice has a very important significance. It heals the mind and the body. And what is happening is that now when they do this pilgrimage to the glacier, they do not take ice from the glacier anymore because the glacier is becoming too small. So as you can see, things are changing, not just for water, but also much beyond this. It can also have this cultural cost. And this has a very important significance, of course. Agriculture, of course, agriculture is already feeling the heat, not just because of the change in climate, but because of the decrease in water availability. And in Kenya, this has already created quite a lot of conflicts, especially people growing French beans or people who have cattle. The people who have cattle are trying to move their cattle to places where there is still water, because the water coming down from the glacier, the rivers coming down from the glaciers are drying up. And so there are a lot of conflicts with cattle being moved into private territories, in places where they shouldn't be. And there has already been quite a lot of crisis in the country taking place. This is a very sad picture. It's actually a picture from Bolivia, from the Chacaltaya Mountains. So there used to be a glacier there, a glacier that was the base of the highest ski resort in the world. And believe me, this is very high. So I'm in the French Alps right now. We don't have ski resorts that high, that's for sure. The ski resort was at 5,300 meters high. So this is really, really massive. And the ski resort was heavily depending on the glacier to be able to sustain very long seasons of skiing. And the glaciologists predicted that by 2015, the glacier will disappear, the glacier of the same name. But the glacier was already gone by 2009. And this is now completely abandoned, sadly. The ski resort is no more. Ecosystems. You know, ecosystems are very, very fragile around these tropical glaciers. And I know that my friends from Colombia know this very well. Some meadows, some places really depend on the water coming down from these glaciers to sustain a lot of endemic species. In Ecuador, for example, there are many, many of these endemic species, and this is the black-faced ibis that actually depends completely on the food that it finds in glacier-fed wetlands. And as the places are drying up, the population is also being deeply affected by this. And as you know, ecosystems is not just one species, but it's the relations between different species that actually are being threatened by climate change and by the retreat of these glaciers. So let's try to finish on a high note, shall we? It seems that the picture is pretty black, pretty dark, and that it might be already too late to act. Well, it's never too late to act. It might be already past the point of no return for some glaciers, but it's still time to save as many of them as we can, or at least to slow down their melting as much as possible. So let's take a look at some of the solutions that could be easily implemented. One thing that is affecting glaciers all around the world, and tropical glaciers quite badly, is biomass burning, whether it's crop burning, whether it's forests burning, or the aerosols that are being emitted by these fires are quite terrible. And this is something that is not good for the glaciers, but of course it's terrible for the populations living around these areas where we still do crop burning today. So this is something that could make a huge difference. Just to limit this and to stop crop burning would make a very positive impact on our air quality and on glaciers in general. We are seeing that in Kenya, there is a lot of reforestation being done at the moment. Of course, you know, you're going to tell me if you want some reforestation to take place, you do need water. And perhaps this is something that can still be done while there is water coming down from these glaciers. And forests can completely change for the better the climate of an area. I was telling you at the beginning, these forests are fantastic cloud catchers. They transpire, they can bring a lot of humidity. And indeed, this is something that can be done, is being done in Kenya, in Tanzania as well, in many, many places in the world. And this is an effort we can all be involved with. Promote renewables, this goes hand in hand. Of course, this is something that is very easy to say in perhaps rich countries or countries that can afford renewable energies. But today, thanks to the Green Climate Fund, there are funds to actually use less fossil fuels and really try to implement and install these new renewable energies. So there are pots of money here and there that are available, and we have to really transition soon enough from fossil fuels to renewables, and this will really make a big difference for the life of these glaciers. In some places where glaciers have almost completely disappeared, they're actually already thinking ahead and trying to recreate artificial glaciers. So I'm not saying that this is the solution to implement in the tropical regions, but this is just one of the solutions that could be used. So this is an ice stupa in the region of Ladakh, so this is in the Himalayas. What is happening in this part of the world is that they're quite lucky that in the middle of winter, they still have running water. But then it's cold enough that if they take this running water from the mountains and sprinkle it, it will refreeze because the air is actually very, very cold. And so what they do is that they build these mounds, these ice stupas during the winter. And then during the summer, because it gets warmer, they will shrink, they will melt and release this water, just like natural glaciers do. And this is a very interesting solution, very low tech, and it works extremely well in these regions. Water regulation, this is a big one. This is a very debated, very discussed question. How can we regulate water? And by regulating water, I mean storing the water during the wet season and releasing it during the dry season. Of course, this will have heavy implications on the ecosystems around these places if we prevent water from flowing further downstream. But this is really a solution to study. And there are many of these reservoirs, kind of open air reservoirs in the Andes. Actually, what works even better is to try to bring some more water to underground water to these aquifers because they are not affected by evaporation as much. So this is a very important solution to study. Some countries are also studying possibilities to divert rivers. And I know that some countries have been doing this for a very long time. If we think about the Colorado River, for example, in the US. But indeed, some countries are thinking about completely diverting rivers just to make sure they get enough water for their populations. So this is a very, very big topic. But to finish, something I think is extremely important and a solution that is really part of the work of Cumbres Blancas and a solution that can make a big difference is education. Without education, nobody will understand why these glaciers are important. Without education, nobody will understand why we need to preserve these glaciers. And this is what the fantastic people of Colombia are doing at the moment. So truly, I will ask you all to try to use your sphere of influence. Tell your friends, tell your families about these tropical glaciers. Make them excited about these glaciers, make them interesting, because the more we know about these glaciers, the more we want to preserve them, and this is good for us, and of course it's good for the planet. So thank you all so very much for your attention. I hope it wasn't too long, and I would be happy to take any questions actually that you might have. Thank you very much.
Thank you so much, Heidi. It's Marcela here again. Actually, let me see if I can put my camera and you. I don't know if you are seeing me. Okay.
Yeah, great.
I'm here. And of course, I wanted to thank you. It was amazing, and I think you have the capacity to engage us and make it in a very easy way. So, as you said, we would love to have some questions. I would just like to put you in a little bit of context. In Colombia, for example, our kilometers of our 6 glaciers, which are 6 different peaks in different regions, it's 32 kilometers. The one that we just visited, which is called Santa Isabel, was 27 kilometers long in 1850. And now it's less than a kilometer. It's 0.66%. Of long, meters long, so less than a kilometer. And you were mentioning these ashes of our volcano. It's called El Ruiz. It's the glacier next to Santa Isabel. And it's an interesting dynamic because the Ruiz, which is the one you saw in the picture, the ashes are not only falling in its glacier, but only in the neighbor glacier that is Santa Isabel. So as you go up, you're seeing the ashes of Ruiz on Santa Isabel. So I just wanted to tell you this shocking reality that we've been perceiving. And of course, there's a lot of hope in our side of the world. There's a lot of ignorance, and today is a Sunday. In most of the places, people are hanging out, and glaciers are not a trend. They're viral when people share on their social media that they're melting. Everybody wants to know, but they're not a trend because still it's not cool. It's not something fun. So I hope that with you and with the effort that we're doing, we can make them a trend, and that learning about them, it's crucial for our common sense and awakeness. And also because they are fun, they are cool, not only climbing them, but they're amazing. So this is some of the efforts that we're doing. And I hope that in the next presentation, you have real pictures of our glaciers that you can show to everybody. So we're really waiting for you here in Colombia. And what I propose now, it's a Q&A. We would love to see who is in the other side of the microphone and the screen. So just maybe introduce yourself if you have a question, telling us where are you connecting from and what's your interest on glaciers, or if you are actually doing something about them. So I'll leave it up to you guys. If you have a question, feel free to unmute your microphone and ask. Don't be shy. Extra questions? Okay, maybe someone is typing here. Yes, we are going to also send you the presentation. You say, and a little correction, the picture of the Colombian volcano with ashes covering the glacier is the Nevado del Huila, not Greece. Okay. Someone else has a comment or wants to make a question, you can do it without just unmuting your phone. If there are no questions, of course, we'll conclude, but it would be great to take this opportunity. It can be on Haiti, or it could be on our project. Otherwise, if you don't have any question and you just want to share us, where are you from and what's your interest on glaciers and what make you interest on this call, on this webinar, we would love to hear. Where are you from? From Medellin, Andres. Great, thank you. I'm actually flying to Medellin in the next couple of minutes. Anyone else? So let me see, there are some, are there any communities in Colombia depending on glacier water? Yes, actually, all of the glaciers are leading to the main cities. We're gonna have a conversation maybe with Heidi if she wants, and the Colombian glaciologist Jorge Ceballos, that he can share with you our current status. This week we have our kickoff with social media influencers, with newspapers, and our glaciologist Jorge Ceballos gave us a status on the current status of the 6 glaciers that we have. So I'm not an expert. I don't think I'm the person to answer most of the questions about our glaciers. So luckily and hopefully we're gonna have a conversation with Heidi and our glaciologist. Another comment here says, you are guiding the national park Los Glaciares Argentina. Amazing, Magali. We would love to connect and maybe talk about what we can do, and why not starting Cumbres Blancas Argentina. Somebody else is from Colorado, USA. Amazing. You guys have a lot to teach us regarding glaciers. People from Manizales and Valledupar, it's here in Colombia. Great to see you. Next time it's gonna be in Spanish. This time we're doing it in English because Heidi is gonna learn Spanish.
For sure. Hi to everyone. Hi to Magali, Christina, Hilda. Very nice to see you here. Hi to all my friends.
Yes, most of you probably already know Heidi from Pennsylvania and teach courses on climate change. This was a wonderful lecture, great photos. Thank you. Amazing. Great, you enjoyed it. So anyone else wants to ask something else? I won't take much of your time then.
I
We'll
do
keep
have
in
a question
touch.
for you, Marcela.
Yes, of course.
I dare to ask. So what's next for you? How do you think you will be able to connect with the populations of Colombia? What is your plan?
Yes, so what's next for us? It's a couple of lines. We are doing expeditions to the 5 glaciers that are missing. On September, we're doing Greece, and on November, we're doing Tolima. We are also including in our expeditions and documentary the ex-glaciers, let's say the glaciers that are already extinct, which are more than 25 in Colombia, but we're gonna focus on the last 8 that, let's say, die or extinct less than 100 years ago. And in June, in a month, we're visiting the first, we call them paramillos or super paramos. And as we go, we're doing a lot of challenges in our social media. So we are involving normal citizens in taking one action a week that they can choose to transform their actions and support the glacier. So let's say naked food. Don't buy food that has plastic. Maybe next week it's gonna be about fashion and why maybe we can use secondhand, or not buying from, I don't know, shops that are not sustainable. So that's a little bit what's going on. As we work, we are preparing the documentary of the glacier that we just visit, and the book that will be released in the next, both of them, documentary and book, are going to be released when we finish the 6 expeditions by year 2021, we hope. So that's a little bit the panorama. We are also in touch with people in Ecuador and Peru and other countries that would like to start a movement like Cumbres Blancas in their countries. Ideally, we would love to have Cumbres Blancas in each region that has tropical glaciers, because it's not only about making a documentary. It's a really about creating a movement around glaciers, around climate change, to just understand the reality and explore them, because we are saying goodbye. We know this is a farewell, but we don't want them to go without teaching us the lessons that they're kind of not hiding from us, but they're not being visible at the moment. So that's it. I hope that answered your question, and we're more than happy to really have you soon here, with your knowledge, your technology, your ideas. And if anybody else is interested in coming to Colombia, open doors for everybody to come and visit us.
Thank you very much, Marcela, and good efforts. Don't give up. You guys are wonderful, and keep on fighting.
Yes, of course. It's a team effort. So I also want to give the credit to all our team members. And well, we'll keep you posted about future conversations we are going to have. Also, follow Haiti. She's doing a great project on the last tropical glaciers, and we'll be connecting soon. Thank you, guys. Really happy to have you all here.
Thank you
See
so
you
much.
soon.
Thank you, Marcela. Bye-bye.
Bye, everyone.